Yeah, so good evening everyone. Let's start our session. So we were discussing about blocking and non-blocking statements in blocking and non-blocking assignments in Verilog. So we will continue this. So we have discussed that about blocking assignments. So a blocking assignments are executed in the order they are specified, and they are specified in a sequential block. And a blocking assignment will not block the and a blocking assignment will not block the execution of statements that follow a parallel block. So we'll consider the case of blocking assignments. So in case of blocking assignments, these blocking assignments are done inside a sequential blocks, that is always an initial block. So we'll consider now always blocks. Say this is our one always block, always at the rate passage of clock. We'll discuss what is this at the rate passage of clock. For now, remember that this block will activate at the passage of clock. I will explain what is this meaning. So this is called event actually. So this is called event. We will discuss about this event in upcoming sessions. So for now, remember this always block will start at passage of clock, and this is end. And we have another always block, always at the rate passage of clock. So this also start at the passage of clock. So this block also will be activated at the passage of clock, begin and end. So there are two always blocks here, and I'm using a blocking assignment. So here I'm assigning A is equal to B. So this is a blocking assignment, and I'm assigning C is equal to, B is equal to A, and here I'm assigning C is equal to A. So I have two always blocks. These two always blocks will start at 0 time units. Sorry, so these two always blocks will be starting at passage of clock. So this is a clock. So whenever there is a positive edge occurring, then these two always blocks will be triggered and this process will begin. So we have already discussed in our previous sessions that the Verilog is a concurrent language. The Verilog is a concurrent language, and the two always blocks will run parallelly with each other. So at the passage of clock, these two always blocks will start, and here the two assignments is the statements, the procedural statements inside the two always blocks will run parallelly. So, but in the statements inside the always block will run sequentially. And since it is a blocking assignment, the first statement will block the execution of second statement. So the execution of second statement will start after the completion of first statement. So when A is equal to B assignment get completed, then only B is equal to A gets started. So for example, if A is equal to 0, then by writing a test bench, if we give A is equal to 0, then and okay, not A is equal to 0, say suppose we will give B is equal to 1. So if we give B is equal to 1, then the value of A will be equal to 1. And next, after completing the first statement, the second statement will get started. So the value of A is 1, so the value of B will also become 1. So the A value will become 1 and B value will become 1. Or else we can also write, if A is equal to 0, then the assignment, this first assignment A is equal to 0 will gets happened, and afterwards B is equal to A, that is B will be equal to 0. So here in the blocking assignments, the assignment will happen one after other. The first assignment will block the execution of the second assignment. The execution of second assignment will start after the execution of first assignments get completed. So the here in the case of blocking assignments, the order of execution is very important. Order of execution is important. Here in the case of blocking assignments, the order is important. The order of execution is important. After the first statement, the execution of first statement completes, then after only the second statement gets started. And here, if we compare the two blocks, here we have two always blocks. So in the first always block, we are giving a is equal to 0 and b is equal to a. So in the second block also will start parallelly, and c will try to assign the value of a. So at the output we will get a is equal to 0, b is equal to 0, and c is equal to 0. Like this, our output will, at the output we will be getting our values. So these two always blocks will run parallelly, and in the blocking assignments, the first statement will block the execution of second assignment. So blocking assignment statements are executed in the order they are specified in a sequential block. A blocking assignment will not block the execution of statement that follow in a parallel block. So here the blocking assignment will not block the statement which is in another procedural block. These two blocks will run parallelly. So this is the blocking assignments. So is this clear, right? This example.
Yes.
We will consider one more example. So always at the rate passage of clock begin. I will assign a is equal to 0 hash 10, b is equal to 1, or else I will assign a is equal to 1. So here what happens, a will be equal to, the value of a will be equal to 0 at 0 time units, and the value of a will be equal to 1 at 1 time, sorry, at after 10 time units. So only after the statement 1 get executed, then only the statement 2 is getting executed after 10 time units. This is, here I am giving a delay, or else I can write this as a is equal to 0 hash 10 a is equal to 1. So like this also I can write it. So after 10 time units, the value of, so here after 10 time units, the value of a is getting changed. So after the statement 1 is getting executed, then only the statement 2 will be executing. So the blocking statements will block the execution of subsequent statement. So here in the case of blocking statements, order is very important, and we will in blocking statements we have inter assignment delay, and we also have intra assignment delay. So we will discuss this inter and intra assignment delay in our upcoming sessions. So for now, keep in mind that in the case of blocking assignments, the order of execution is very important. So this is about blocking assignments in Verilog. Now, coming to non-blocking assignments. Non-blocking assignments allow scheduling of assignments without blocking execution of statements that follow in a sequential block. So again, I will take one sequential block always at the rate passage of clock. So this block will get activated at passage of clock. I will explain what is this passage of clock, negage of clock. So this is basically an event. So I will explain this about this events also in upcoming sessions. So within a begin and block, I am assigning a is equal to 0 and a is equal to, okay, for now I will assign a is equal to b and b is equal to c. Like this I will assign. So here what happens, this is a non-blocking statement. This is a non-blocking assignment. So in case of non-blocking assignments, what happens? The statement 1 and statement 2 run parallelly. These two statements will run parallelly. the statement 1 will not block the execution of statement 2, or statement 2 will not at all block the execution of statement 1. So here the order is not at all important. Order of execution is not important. So in case of blocking assignments, order is important, whereas in case of non-blocking assignments, order is not important. That is, A will be having the value of B, at the same time B will be having the value of C. At the same time, A will be having the value of B and B will be having the value of C. So if A is equal to 0, okay, so if B is equal to, not B is equal to, uh, if I have the value, if I drive the value of C is equal to 1, then at 0 time unit, B will be equal to the value of 1. So B will be equal to 1 and A will also be equal to 1. This will code in the simulator and we will check it. So here for now, understand that in case of non-blocking assignments, the order of execution is not at all important and the statements will not block each other's. Here there is no blocking of statements like in the case of blocking assignments. So is this clear for everyone? In case of blocking assignments, it is running sequentially. After execution of first statement, the second statement start executing. But here in case of non-blocking, these two statements will run parallelly or concurrently. Is it okay?
Okay.
Yeah. So I will take one more example. So always the rate of usage of clock begin and A is equal to 0. A is equal to, I'm using intra assignment delay. I will explain it later. A is equal to,
Yeah,
yeah.
inter assignment is used in blocking statement or intra non-blocking
No, no,
assignment.
no, no. I will explain about it. Not like that. I will assign A is equal to 6 and so I am taking intra assignment delay here. So this is a non-blocking statements I am using and these are running concurrently or parallelly. So here these statements will run concurrently. So here what happens, we are assigning A is equal to 0. Here this is at 0 time units and this is at 1 time unit. Okay, I will change the variable B, C, D, E and this is at 10 time units, this is at 5 time units and this is at 3 time units. So here what happens at the output at 0 time units, we will get the value of A is equal to 0. And in the case of non-blocking statements, what happens internally is, for example, we will take the case of B is equal to hash 1 1. So in case of non-blocking statements, what happens internally is, at if we mention any delay like this intra assignment delay or inter assignment delay also, in the both cases what happens if we mention any delay, so at 0 time units what happens is, here our value 1 will be stored in an internal register. So simulator will store the value of 1 in an internal register at 0 time unit only. So simulator will store the value of 1 in an internal register at 0 time units. Here not only 1, our 10, 6, 4, all these values which are having some delay associated with. So all the values which are having delays with it are stored in some internal registers at 0 time units. So all the values which are having delays with them are stored in internal registers at 0 time units. So the simulator will store the all these values in some internal registers. So at 0 time units. So if we consider the case of b is equal to hash 1 1, then 1 will be stored into some internal register at 0 time units, and after 1 time unit the 1 will be allocating, or it will be assigned to our b after 1 time unit. So after 1 time unit the value of b will be equal to 1. So like this, the simulator will store all the values into an internal registers, and it will assign the value to the left hand side after completing this specified delay. So here at the output we will get a is equal to 0, and after 1 time unit we will get b is equal to 1, and here 3 is the least delay after 1. So after 3 time units we will get 3 time units, we will get C, not C, A, B, C, D, E. We will get the value of E, which is equal to 4. And after 5, after 3, it is 5. 5 time units, we will get the value of D, which is equal to 6. And after 10 time units, we will get the value of C, which is equal to 10. So this is how we will get the values, we will get the output in case of non-blocking statements. I will explain the case of blocking also. So I'll take the case of blocking a is equal to 0, b is equal to 1. Okay. So within an always block, I will take a is equal to 0, b is equal to hash 1. See the difference here. B is equal to hash 1 1, and c is equal to hash 10 10, and c is equal to hash 5 6, and d is equal to hash 3 some what I will do 4. So I'm using here blocking assignment. See the difference between the blocking and non-blocking. So you will, so this is blocking. So what happens here? After 0 time units, we will get the value of a is equal to 0, or at 0 time units we will get the value of a is equal to 0. And remember, in case of blocking assignments, order is very important. Order is very, very important. In case of non-blocking, order was not important. That's why we are getting the values which have least delay like this at the output. But here in the case of blocking assignments, the order is very, very important. So here after 1 time unit, we will get the value of b is equal to 1, and after 11 time units we will get the value of c is equal to 10. So after completing this 1 time unit delay, the simulator will come to this statement, and after completing 10 time unit, so here already 1 completed and plus 10. So total 11 time units delay. So after completing 11 time units delay, we will get the value of C is equal to 10. And the simulator will come to the next step. So here the simulator has completed the delay of 10 plus 1, 11, and after completing plus 5, that is 16. So after 16 time unit delay, we will get the value of D. Sorry, here it is D and it is E. We will get the value of D is equal to 6. And after completing 16 plus 3, that is 19 time units, we will get the value of E, that is equal to 4. So here after 0 time units, we will get the value of A and plus 1. So after 1 time unit, we will get the value of B and plus 1 plus 10. After 11 time units, we will get the value of C, and after 16 time units, we are getting the value of D, and after 19 time units, we are getting the value of E. Whereas in case of non-blocking assignments, the output we can see we are getting A, afterwards we are getting the value of E, and then we are getting the value of D followed by C. So here the order is not at all considered. The statements which are having less delay are executed first, but here in case of blocking statements, we can see clearly that the statements are getting blocked by previous statements, and here the order is very important. So this is the blocking and non-blocking statements in Verilog. So is this clear for everyone? I'm adding delay, right? Here you can
Uh,
see. So this is a delay.
yeah. Okay,
Hash
okay. Yeah.
So in non-blocking, it is not at all considering the order. It is considering the statements which are having less delay. So A is equal to 0 has less delay, 0 time unit delay. So we are getting A is equal to 0 at 0 time unit. And after the delay is 1 time unit, so we are getting B. And after 3 time units, we are getting the value of E. Here we can see after 3 time units, we are getting the value of E, like this we are getting.
Yeah,
Okay.
yeah, okay. Clear.
So is it clear for everyone? It is very
Yeah.
important. Sometimes so many interview questions, many in many written tests also, this type of questions will be framed, uh, like what will be the output, write the output, or predict the output. So they will give some set of blocking statements and non-blocking statements, and they will ask what is the output, like that. So you should be careful in this type of questions. So is it clear for everyone?
Yeah.
Yeah. So now I will mix both blocking and non-blocking. I will write A is equal to 0, A is equal to, wait a minute, A is equal to hash 5 1 10 B, C is equal to hash 10 2, D is equal to 6, and E is equal to 7. So I've mixed both blocking and non-blocking statements. So here we can see at at the output at 0 time units, we will get the value of A, which is equal to 0. So at 0 time units, we will get the value of A is equal to 0. And if we are using both blocking statements and non-blocking statements, then the simulator will evaluate blocking statements first. So blocking statements are evaluated first, and then it will go to non-blocking assignments. So sorry, this is blocking assignments. So blocking assignments will be evaluated first, and afterwards the simulator will go to non-blocking assignments. So here in this case, the simulator will first evaluate blocking assignments. That is, A will be equal to 0 at 0 time units, and after 5 time units, we will get the value of B, which is equal to 1. And after 15 time units, we will get the value of C, which is equal to 2. And after 15 time units, we will get the value of D and E also. So after 15 time units, we will get the value of D, which is equal to 6, and value of E is equal to 7. So here there is no delay mentioned. So that's why these two statements will execute parallelly. So this is how the output will be when we mix both blocking and non-blocking assignments. So is this clear for everyone?
Yeah. If delay is used, then
What? Can you repeat again?
if delay is used in non-blocking assignment, then
Yeah,
what happens?
yeah. If I use E is equal to hash 2 7, and here hash 1 6, then after 15 plus 1, then here at 16 time units I will get the value of D, which is equal to 6, and so up to here it is 15 time units delay. So here 15 plus 1, that is 16 time units, I will get the value of D is equal to 6, and 15 plus 2, that is 17 time units, I will get the value of E. So yeah, this is a very good question asked by you. So I'll use one more example. B is equal to hash 5 1, C is equal to hash 10 2, and D is I will use one non-blocking statement like this, hash 1 6, and again I will use a blocking statement here. E is equal to hash 2 7. So here what happens, up to here it is normal like discussed previously. So up to here 15 time units delay will be added, and from this it will not evaluate non-blocking. First it will evaluate blocking. So it will, after 17 time units we will get the value of E, that is, which is equal to 7, and after 17 plus 1, that is 18 time units, we will get the value of D, that is equal to 6. So is this clear? So first blocking statements will get evaluated, then after non-blocking will get evaluated. So is it clear?
Uh, Explain once more again.
Yeah. So what happens here? A is equal to 0, B is equal to hash 5 1, D is equal to 3, and E is equal to hash 1 4. So this is a scenario we are having. So at 0 time units we are getting the value of A, which is equal to 0, and after 5 time units we will get the value of B, which is equal to 1, and after 15 time units we will get the value of C, which is equal to 2, and after, so up to here it is 15 time units, so 15 plus 1, that is after 16 time units we will get the value of E, which is equal to 14, and after I will add one more delay here, hash 1. So after 16 plus 1, 17 time units, I will get the value of D, which is equal to 3. So this is the blocking and non-blocking assignments. Is it clear?
Okay.
Yeah. So these are the blocking and non-blocking assignments. Please wait a minute.